I'm going to show you how to change AC into DC, but first I have to tell you how we're going to do this in theory. What we need is a transformer. We have 110 volts coming in here, AC, and here we have another voltage coming out that's much lower, like maybe 18 volts or something, AC. There's another kind of transformer that looks like this, with double winding. It has 110 volts coming in AC. And for example, it has 9 volts AC coming out and 9 volts AC here. Between those 2 points you have 9 volts, and between these 2 points you have 9 volts. And between this point and this point you have the sum of those two, so you have 18 volts here. So these are the two transformers we're going to talk about. There is 3 different ways you can do this. With this kind of transformer you can use one diode, and then you have the AC coming out here. AC is like this. The diode is going to cut off one half of the cycle here, because it only conducts when this is positive here, positive, then it will conduct, but when it's negative the diode will not conduct, and then what we get out here is only the positive cycle coming through. Cut off the negative, so that's what we have here. That's the output, in, out. You see here we have a DC voltage that's only positive. Positive, 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 negative, positive, negative, positive. Now to improve this shape here, because it's like bumps here, we can put a capacitor here. So this is our load, light, let's say a light here. So when it's conducting, the positive side is going to go through the light and it comes on, but at the same time it's going to charge the capacitor, and then at the next cycle when it's negative, there is no voltage coming out from the transformer, but there is voltage on the capacitor, and the capacitor is going to discharge its voltage through the light, and the light will come on for the next negative cycle. So what happens is, in this case it's going to conduct, the capacitor is going to charge, but the negative cycle there's no more voltage, but then the capacitor is going to discharge and give voltage during the negative cycle. Then when it's positive again, the capacitor is going to charge up again. When it starts to become negative here, the capacitor is going to discharge, and we're going to have a voltage like this. So it looks much better than what we have here without the capacitor. Now the bigger the capacitor, the better this shape is going to be, because the capacitor has more charge, then it takes longer to discharge, so it's going to be very slow, it's going much slower, and it's going to be like this. If you have a smaller capacitor, it's going to discharge very fast, and then it's going to go like this. See? So the bigger the capacitor, the better shape you have here, the more straighten it out. So if we have a real big capacitor, we're going to have something like this. Very little rumble. So this is one way. Then the other way is with this kind of transformer is using a bridge rectifier, like they call it. And this is going to be our load light. So we have this transformer here with a double winding, 9 volts AC. Here we're going to use 2 diodes hooked up this way. And our load is going to be between those 2 points here. This is going to be our light. So when this is going to be positive, here is going to be negative, positive here, negative there. So when this is positive, it's going to go through here. It's going to go through the light, and it's going to be negative. So negative here and positive there. On the negative side here, nothing is going to happen because the negative doesn't go through in this way. So when we shift polarity, this is only going to be positive, negative, positive, negative. When this is negative, nothing is going to happen here. But positive here, it's going to go through, positive, through here, negative here. So one cycle is going to go through this way, the next cycle is going to go this way. But we're only going to have 9 volts over the light here. It's only going to be 9 volts. In previous case we had the complete 18 volts over the light bulb. Now we have only half, because it's only half one cycle and the other half the other cycle. So we have the same thing like before. It's going to be like pulses like this, positive pulses. And we put the capacitor again in parallel here. So the capacitor is going to discharge, discharge, discharge here. And we're going to have the same thing again. So that's what we're going to do. That's all. Now I have to explain you what the difference is between AC and DC. 110 volts AC is not, this is 0 here. It's like about here, 110 volts. This is 110. But we actually get more than 110 volts from peak to peak, they call it, peak. Peak to peak. This is called 110 volts AC effective voltage. Now there's a formula. This is called 110 volts This is called 110 volts AC, like we said, effective, or RMS. It's like an average of, if we change this to put everything on the top, make it all positive like this, put this negative one on the top, then make it over here. That means that this part is covering this part here, this part is covering this part, this is covering this, and it makes it like a, if it was like a 1 like as if it was DC voltage. And that's what it's called effective, because when all this area here, there is nothing much going on here. Only this part here is there is some energy, and here is energy, and here, but here there is nothing. So they put everything on top, make an average, and that's it's not really an average, but that's the effective voltage. That's what you call 110 volts. Now the peak-to-peak voltage is, there is a formula, it says voltage peak-to-peak is voltage RMS times 2.828. Okay. So in previous examples we had RMS was 18 volts AC times 2.828. So our peak-to-peak voltage is 50.90 volts. And in our other example with the 9 volts voltage, peak-to-peak is 9 volts in this case, with a double winding times 2.828, and the peak-to-peak voltage is 25.45. So when we rectify this, and we have all these peaks here on the top, with the 18 volts AC, so our peaks are going to be, it's going to be 50.90 if we have the negative one here. This here is 50.90 peak to peak. So when only the top peaks is going to be only half of it. So from here to here, we're going to have 25.45 volts. Okay. And in the other case with the 9 volts, we only have half of this here. .73 volts. So in our first case, our DC voltage would be, if we have a very big capacitor, let's say it discharges very little, we're going to have very close to 25.45 volts of DC voltage here. In the second example, with the two diodes, we're going to have, with a very big capacitor, we're going to have voltage very close to 12.73 volts DC. So now we're going to put that all in practice and see if we get close to these numbers here. Today I'm going to teach you how to transform AC voltage or current to DC current. What we use for that is diodes. I have some diodes here, like this one. See, they're usually black, and they have one white line going all the way around. That's the negative side. The black side is the positive side. So that's what we're going to use. And we're going to use the diode, and we need also a transformer. To transform the 110 volts that you have in your house, we have to transform it down to like 16 volts or 20 volts. So we'll find out how many volts we actually need. I will tell you that later on. You can use a transformer like this kind that you can plug into the wall, like power supply for your calculator or something. And then I cut out the connector here. This one it says, I don't know if you can read it. This one it says 120 volts and 12 volts AC, that's what you want. Output is AC, alternating current. Because most of this kind they have DC output already. But we are going to do it ourselves to change it to DC. They have the circuit already built inside. You plug in 110 volts and you have like 6 volts coming out or whatever you need for your calculator or your phone or something. But this one is 120 volts or 110 volts. And the output is AC, 12 volts AC. So that's what you want. You can also use this kind of transformers. This one it says 100 to 120 volts and the output is 2 times 9 volts and 2 amps maximum power. You can use 2 amps maximum. So 2 times 9 volts, it has 2 red wires and the green one. So between the green and the red is 9 volts, and between this one and the red one is also 9 volts. Between the red and the red we have 9 plus 9 is 18 volts. So here we have 18 volts, here we have 9 volts, and here we have 9 volts. So we can choose between 3 different voltages, 9, 9 or 18. And this is the input, 110 volts in. So this is kind of a little bit of a special transformer because of the middle connector here. It splits the voltage 18 volts in 2 times 9. So we're going to talk about this later, how we're going to use this. But for now we're going to use only the 18 volts. We're not going to use this one for now. So let's get started, and I'm going to hook up a 110 volt wire to the, first we're going to start with this one. We're going to start with this one, the easy one, and we're going to use only one diode. So let's get started. We're going to use one diode, that's it. We're going to hook it up to either side here, and now we're going to have DC coming out here. Between this is the output, the current is going to go through the diode here, to one diode. What the diode does is let the voltage go through one side but not to the other side. So we have AC current is going up, positive, and then negative, positive, negative. This one is going to let only one side through, only positive or only negative, depending how you hook it up. This way, or you flip it over, then it's going to be the other way. So I'm going to show you on the oscilloscope and see what we get here. First I'm going to plug in my power here. So let's check what we have right now. So we have 5, 10, 15, 17 volts. How much does the voltmeter show us? Let's check this here. On the meter it shows that we have only 6 volts. See? But on the oscilloscope it shows us that we have 20 volts because it's averaging out. Now if we put a capacitor there at the output, then it's going to charge up when it's loading up, and then it's going to discharge and keep some voltage here and then discharge right away here like this, depending on the load that we put up there. Let's see, if we put a small capacitor, I have here a 1 microfarad capacitor, that's very small, so let's put that in there at the output. And see, now we have 18 volts. Here it shows 5, 10, 15, 20. See, there is no more sine wave because the capacitor is charging when it goes up and discharging when it goes on the negative side. And the voltmeter shows also 18 volts now. The only problem is when we connect a load at the output, then everything is going to change, of course. I have here a 10 kilo ohm resistor that I'm going to use as a load, variable resistor. I'm going to hook that up at the output. If I change the load, see, if I put more load, then it's getting worse. If I put less load, oops, then it's getting better. Now I have 10 kilo ohms load and it's still not so very good. The voltage is low. If I increase the load, if I extract more power from the power supply, then the voltage is going down because the capacitor doesn't have enough charge. So now let's put a bigger capacitor there. Instead of a 1 microfarad, I'm going to put a 1000 microfarad. Let's see if that's. But be careful because these capacitors, they are electrolytic capacitors. They have a polarity. So this side has to be hooked up to the negative side. You see the line here with the negative sign. So we have to hook up the negative here. The positive is going to be there. So the positive is going to be this one here, the green one. Positive. And this one negative. And you see now what's happening with the bigger capacitor. We have 18 volts and nice straight line. Now if we increase the load here, less resistance, then it's still keeping its thing. Now at the end it's going down. But this is pretty good. Even the voltage keeps the voltage at 18 volts. Even with a big load here. Now things change if we use like a capacitive load, like a coil. instead of a resistor. Let's use this thing here. I have here a beeper. Let's use the beeper as a load. There's a polarity here too. Positive. See, there's a beeper here. It says 4 to 28 volts DC. Okay, positive here, negative there. Whoa. Okay. The voltage goes down a little bit when I use it. Let's try a load with a coil. I have here a little fan. Says 12 volts DC, 1.4 watts. Let's see what happens when we hook up a inductive load. This is going to eliminate some of the power of the capacitor. See? Now the fan is blowing and you see the capacitor has a few problems there. See, now the capacitor is discharging a little bit and charging again. So as you can see, we have 15.8 volts with a inductive load. No load, we have 19 volts. So that's what we're gonna get. That's what we should get, 16.197 volts. 16.197 volts. That's what we are reading right there. Well, we have 19 almost. Well, do we get 12 volts AC? Let's check that. Maybe we have more than 12 volts AC. We have 13.8 volts. We have 13.81. We don't have 12 volts, we have 13.81. So if we do that, 13.81 times 2.8284 is 39.06 divided by 2. $19.53. That's what we had there, 19.53, right? So this is our zero line. Let's check. So we have 5, 10, 15, almost 20 volts. Supposed to be 1953. Let's see how much our meter measures here. We calculated 19.53 volts and we have 18.3 volts. So calculations and reality don't come out really 100%, but it's closer. This is how you do it with just one diode. Now we're going to do it with a bridge rectifier. We're going to use 4 diodes. So let's do that. 4 diodes. And with 4 diodes we would have instead of one peak and then nothing and another peak, we're going to have peaks at the positive and the negative sides all we're gonna have the positive peak going up to the top side. So we have one peak after the other. Not one peak, one missing, one peak, one missing. So you will see. For this we need 4 diodes. So we have 4 diodes here. These are all used diodes. I took this out from an old spotlight from a theater. Had a lot of electrical components in there that I took out. So I'm going to solder those together. So the way you hook this up is we have to put the positive and the negative side together on one side. Positive and negative. So let's do that. Okay, these ones are together. Now here the same thing, a positive and a negative together. Positive and a negative. Okay. Now here we have to have 2 positives together and 2 negatives together. So one line here, one line there, that's the negative. Dark side, that's positive. So I'm going to put this together like that. Now let's hook it up and see how that works. Now, so I'm going to use the same transformer with the 12 volts AC output. And for this, how to hook this up, we have to hook up the one wire to the where the positive and the negative comes together, and the other side on the other side where the positive and negative comes together. So let's hook up our oscilloscope and see what it shows here. See, now you see we have loops everywhere. We don't have empty spaces here in between like before. The voltage is still the same, the peak voltage. That didn't change. Now if we add a capacitor to it, now the capacitor is not going to discharge so much because the capacitor had to discharge from here all the way down to the next one. Now it's much shorter. Now it has to discharge not so much, just a little bit, boom, and then we have the next one. Boom. Before it was discharged from here all the way up to there. So now we can use smaller capacitors. Negative. This is negative. Now we have a nice straight line. Hook up here the capacitor, the inductive load, and see what it says. You still have a little ripple there. Oops. Now our beeper. Positive. see barely any difference, but with the inductive load you can see a little bit of ripple. So this is a better system than just with one diode. You have better regulation. Now these diodes, they come already made like that in one chip. You can buy those in one chip. Actually, much easier. You don't have to make it yourself. You can buy those used already. These are the four diodes that we made here. They're already built in one chip, like that. Okay. It's got a 400 volts bridge rectifier, 4 amps. And here are the ones one that took out from that see here they show the 4 diodes, positive and negative together here, and positive and negative together. There's the input of the AC, and where the negatives and the positives together, they have output is negative and the positive output. So let's hook up this one and see what we get. Now the 2 center ones, they are the AC. And now we're going to hook up the oscilloscope and see what we get out. The left side is plus. You can see here on my drawing. So they show it here too in the picture. The left side is plus and the right side is minus. So this is minus. This is plus. And there we get the same thing as with our bridge rectifier, as with this thing here. The only thing is this is easier to make because you just go to the store and buy it and that's it, you're ready to go. You can hook up a capacitor to the output. Oops, this is negative. Positive. There we go. Let's hook up the blower here. And you see the little variations there. It's all the same. The beeper. So that's it. Now there's one more way to do this, and that's with 2 diodes, but you need a special transformer for that one. You need to have a transformer with 2 outputs. See, like it says here. Output, input 100 to 120 volts AC, output 9 volts, 9 volts. So we have 2 times 9 volts. The green is the center one. Between those 2 we have 9 volts, and between these 2 we have 9 volts. The green and the red one. Between this green and red one we have also 9 volts. And we have 18 volts between these 2. You can use these 2 if you want a higher DC voltage. 18, you have to use your formula and you see how much volts you get out with an 18 voltage. You're gonna have like maybe 30 volts DC or something. So we're gonna use this double coils here, and then we can use 2 diodes. The way we're going to hook it up is like this. We have a transformer, the 110 volts here, AC, and we have 2 windings, 9 volts AC, 9 volts AC, and we're going to use 2 diodes. Hooked up like this. And our output is the center coil, the center point here, and the middle of these two here. That's our output. DC. So we're going to have the same effect as a bridge rectifier, you know, where we have the output is going to be like this. But the voltage is going to be much lower. Now we have 9 volts AC. If we calculated that 9 volts AC with our formula 2.8284 times 9 equals 2546 divided by 2, 12.73 volts DC. That's what we calculate when you use the system with 9 volts. So what happens is one time it's going to conduct this way to there, and the next cycle is going to go to this side here. When this one is positive, this one is negative, it's going to go from here positive through here, and this one is going to be negative, this one is going to be positive, and when this one is negative, nothing is going to happen here. But when it switches over to negative here and positive there, then this one is not going to conduct, then this one is going to conduct, and it goes through here, output. So one time this one is going to give the output, the next cycle this one is going to give the output. So we're going to have like this, and this is going to be our voltage. So let's do it and check it out. So 2 negatives all together here. One side goes to this side. So the output is going to be the green wire, the center, and the middle between the 2 capacitors, the 2 diodes there. And what we got here is 5, 10, 15, about 17 volts. And we calculated 12.7. So 15 volts is it? About 17. Now we're going to use a capacitor. Where's our capacitor here? Positive and negative. It's here. We got a nice straight line, see? then let's measure the voltage with the meter here. What do we have? See, we have almost 12 volts. Supposed to be 9. Oh, no, we calculated, yeah, 12 volts, 0.7 volts, that's what we calculated. 12.73. So that was good. And we're gonna hook up that fan here. And we get the same rumple there. Let's try our beeper. Yep, everything works the same. So there's another thing. Also, this one it comes like already you can buy like a chip. See here, 2 diodes already hooked up like that, and the chip looks like this here. That's it. The 2 outer pins is the AC, and then the center is the output. Let's hook it up and see what we get. Our output. Output is our center, and the center here. And we got the same thing. Let's hook up our capacitor. Red is negative. There we go, nice straight line. Hook up. Fan. You get the wrinkle there. The beeper. Everything works fine. That's it. These are the 3 different ways you can change the AC voltage to a DC voltage. And then you can add some more stuff to stabilize, or you get voltage regulators to keep the voltage at a certain voltage that it doesn't change at all. Like you can have 5 or 10 volts or whatever, like nice, smooth. It doesn't. You can hook up whatever you want, but it's like a more sophisticated circuit. So that's it, and hope you have fun and learn something.